We're going to review for the unit test on Monday. And then senior signing day, and then the rest of that week will be review for the common assessment. Okay? So, for this lesson, I know a few people have kind of coming in and out. We've actually done this a few times. It's very similar, but it's kind of just adding on to it. So I'll try to go as slow as possible, make sure that everybody at least has some sense of what's going on. If not, this lesson actually, out of the most that we've done, is the most procedural, meaning that you can typically just follow a pattern and then be at the answer. But I would be a lot more comfortable that if you miss stuff, go back, watch the videos online. They should all be uploaded. Make sure that you understand the conceptualness and what's actually happening here, because then that would make it a lot easier to understand this too. But if for today you just want to memorize what's happening, kind of the procedure of doing it, then I would just do that too. Alright, so let's talk about derivatives. So far, we've been using a formula to try to find the slope at a single point, or the tangent line to a curve, right? Today we're going to talk about derivatives. So, let's talk about finding a derivative, right? And so, the derivative of f of x, which we notice is f prime, just don't worry about it, just leave it, is going to be, f of x is going to be the limit as h approaches 0 of this. Now, to some of you, this might look very familiar, right? And there's a reason that it does, because this is essentially the tangent point formula, right? So this is essentially the tangent point formula that we've learned about. So when we want to say the tangent t of at x equals 2 of x squared, we would just go through that whole process of doing this, then plug in the 2, see which one pops out, right? Today, we're going to talk about the function that is actually made by doing this, so you don't have to necessarily plug anything in. And that is what we call the derivative in calculus. So, let's see how we can find this derivative. It's pretty much the same process as finding the tangent thing, but Sergio, can you read this example?
Find the derivative of f(x) equals 4x squared minus 5x plus 8. Then evaluate the derivative at x equals 1 and x equals 5.
Alright, great. So for this one, we're going to go ahead and use this. So first we write the limit as h approaches 0. So that's the first thing we're going to want to write down. So be sure you write that down. Write that down. So be sure you write that down. Computer's about to run out of power, so got to plug it in. Okay, so next thing I'm going to do is go ahead. I like to make a big fraction symbol just so I know, because I know I'm going to need it, and also it helps to separate stuff. Okay, so we'll go ahead and write a big fraction symbol there. Okay, so what I'm now going to do is, so I see this, f of x plus h, right? Everybody see the f of x plus h. So what I'm going to do here is I'm going to say, okay, I'm going to have this function, but everywhere I see an x, I'm going to plug in a x plus h, right? So, for instance, right here, I'm going to write a 4. Then I'm going to write a parentheses, and I'm going to put a little square up there. Now again, normally what would be happening here is I would put an x where that parentheses is, right? But again, this is not f of x, this is f of x plus h. So here I'm going to write a x plus h, right? Okay? So next, what I'm going to do, I keep going. So minus 5, again, normally x goes here, but what's going to go here now? X plus h. And then of course you have this 8, you just write plus 8. Alright? So then, now you're going to have to subtract the original function. So what you do is you put a subtraction sign, and then you put an open parentheses, because you have to subtract the entirety of the function. So that negative is going to carry through the whole function. And so, the function, you just write down the function what it is, because it's just telling you to do f of x, right? So you're just going to say 4x squared minus 5x plus 8. And that's what you write. And this is all going to go over what? H. You have to put it all over H. All right. So now we have to simplify this, right? We have to simplify this. So the limit as h approaches 0, another fraction symbol that is terribly written. Okay. So again, I want to keep this 4 in front of that. But for this one, remember, I'm going to tell you what's the mistake you don't want to make here. Don't distribute the exponent. That's bad news bears, right? Don't distribute the exponent. So, what you can do, what if this is algebra, what could you do? Yeah, you want to use the X box, right, to do that. So you do your little box, XH, and then do all that stuff. But remember what I told y'all the other day, which is that whenever you see an X plus H here squared, there's actually a shortcut, right? What you can do is you can just say, okay, you're just going to say the first term and square that, plus the two terms multiplied together times 2, and then the last term h squared, and you're done there. And that's kind of just a simple way so you don't have to keep doing X box. Every time you see something plus something squared, you can just use that and kind of skip a lot of steps. Alright, with this minus 5, all we got to do there is what? We just got to distribute it, right? So minus 5x minus 5h. 8 still hanging around. What do I want to do with this negative right here? Let's distribute that too. 4x squared plus 5x minus 8. Like Fidel Castro, we're distributing. And then over h. Or Mao Zedong. He was the leader of China during when they were actually communist. It's weird because they're still communist. They've just kind of moved more towards like a market-based economy, even though by name they're still communist. All right. So, one more thing we want to do here. What's that? Yeah, let's distribute this 4. And warning, this is going to get pretty long. So, make sure that you follow. So 4x squared, 2 times 4 is 8xh, plus h squared, 4h squared, my bad, minus 5x, and then all the rest of this crap. Minus 8 over h. Yeah, I know. So, anybody notice anything that cancels here?
8.
Yep, 8 cancels, so that's 8 cancels, 5x cancels, 4x squared. Pretty much anything without an h is going to cancel, right? So if you have everything with an h in the numerator, you're pretty much not going to cancel it, right? So we write down what's left. It's going to be 8xh plus 4h squared, that term, minus 5h all over h. All over h. Anybody know the next step here? Yeah, you want to factor out, there's an h, common h in the top in the numerator. So you want to factor that out. 8x plus 4h minus 5 over h. What happens to those h's? They go away, they cancel. And you're left with the limit as h approaches 0, the 8x plus 4h minus 5 And of course, so, now we evaluate the limit. And how can we evaluate the limit? What do we do? Yeah, so whatever h is going to, we plug that in, or whatever this variable is going to, we plug that in now. So h is going to 0, so we just plug that in. So that will be 8x, so I'm going to go up here now. 8x plus 4 times 0 minus 5, that's going to go away. And so the derivative, so f prime of x, is going to be 8x minus 5. So again, what is that saying? What is that equation telling us? Well, basically this equation, what it does is it gives us the slope at any point on the curve. It gives us the slope at any point on the curve. So I can plug in a number, find out what the slope is at that point. Specifically, this question. Antonio, you want to read the second one?
What does the derivative tell you about the behavior of the graph of f of x at x equals 1 and x?
Good. So if we want to know the behavior of the derivative at that point, what do we have to do? We just plug this in. Eileen, are we going to plug it into the function or the derivative? Good. We want to plug it into the derivative. So this thing up here. So we're going to say f prime of 1 and f prime of 5. So we're plugging numbers into that equation. So it's going to be 8, 1 minus 5, which is 3. And 8 times 5 minus 5, which is 35. Now, what is that saying about that at those points? Well, one, yes, it is increasing because of why? Because it's positive, right? It's increasing, so that means it must be, at that point, the curve must be going on an upward trajectory. Second point is that, remember, this derivative gives us the tangent point formula. So this actually gives us the blank at that point. Starts with an S. Slope. Good. So this is the slope of the tangent line at x equals 1 and 5. So it's the slope of the tangent line at 1 and 5. Good. So any questions there? Alright, so we've done this ad nauseum. There are some practice questions, but I'm going to leave those to y'all because I'm sure we have to move on to something and not have to do that over again. But you will be expected to know how to do that on the unit test, so be sure that you do that. Now, here's the part of every calculus class where the students are like, hey, we didn't actually have to do all that work because there's a lot simpler way to find derivatives, and the professor or teacher's like, yeah, you're right, but hey. So, that happens in every class. It happened to me at TCU, it happened to me at Rice, it happened to a bunch of students, it happened to calculus instructors at Cox. So, what that is that we don't have to go through the whole thing, that whole limit process to find derivatives, right? There's actually a rule and a set of rules that you'll learn actually when you take a calculus course that are kind of shortcuts to finding derivatives very quickly. Here we're only going to learn about one, and it's the simplest rule called the power rule for derivatives. So rather than going through that whole limit process, what we can instead do is so for instance, if we have a function x to the n power, to find the derivative, all we have to do is take the derivative, put the n in front, and then subtract 1 from the exponent, and boom, you have your derivative right there. Right? Don't have to go through all that limit process. And if you want to check the other ones, try it out. It actually works out with the ones we just did.
Didn't we do that yesterday?
Yeah. So as an example, for instance, f of x, if it's x to the 4th, its derivative will be 4x to the 3rd, putting the 4 in front, x, subtracting 1 from the exponent. Okay, so let's do a few examples. These really aren't that bad, I promise. So here we have f of x is equal to x to the 9th. Okay? All we got to do is say f prime of x. Just put that 9 in front, so 9x. Take away 1 from the power, and that's going to give us 8th power, and that's it. So that took that one out, right? Pretty quick, pretty clean. Let's do 2 more. Let's do some cases that are a little more nuanced, but still not too bad, because they require more of a knowledge of algebra. So, let's look at this one. Now, if we recall, remember that if you have x to some power rooted to some other power, b or whatnot, you could rewrite that as an exponent. Specifically, you can rewrite it as a fractional exponent, right? So you can always rewrite these radicals as, does anyone know? X to the a over b. A over b, right? So as an example here, if I have x squared with a third root around it, that's going to be x to the 2/3 power, right? So just an old friend from algebra that we might have forgotten to help us do derivatives. So we do it here. So we have x to the 7th with a 5th root around it. So I'm going to want to change that. So I'll rewrite that. So we're going to want to change this to x to the, so we take the top number, 7, and then put the rooted number at the bottom, so 7 over 5. Yes. That's not that we've just changed it, because now we can do the derivative, right? Now it's more obvious what the derivative will be, because we just follow the rules of the derivative. We just put the exponent in front, so we say 7 over 5. And then we say x, and then we subtract 1 from 7 over 5. Does anyone know what that is? 2/5. And in case you're wondering, remember 7 over 5 minus 5 over 5, I'm just subtracting 1, right? That gives me 2 over 5. And that's my derivative. Okay, one more. This is easier. So we have 1 over x to the 8th. Remember, if you recall, if I have 1 over x to the n power, how can I rewrite that with what kind of exponent? What kind of exponent? So we've used fractions. What other kind of numbers do we know about? Negative numbers, right? Remember negative numbers. So 1 over x to the n you could rewrite as x to the negative n, right? So again, if you want an example, 1 over x to the 3rd is the same thing as saying x to the negative 3 power. Right? This is just an old rule from algebra. And so, we're going to rewrite this h of x to the 1 over x to the 8th power. We're going to rewrite it as x to the what? Negative 8 power. Good. We write it as x to the negative 8 power. And so I'm taking the derivative of that. So what do? Okay, so it's going to be negative 8 x to the, not negative 7, negative 9. Remember, you got to subtract 1. You got to subtract 1. So that would be our answer. All right, so any questions over this? Again, typically easy. Sometimes you got to do a little bit of an algebraic manipulation to get the answer that you so desire. All right, go ahead, turn to page 4. Try those 3 problems. I will give you about 3 minutes to try those out.
So what are you going to do
Over the summer? Teach some SAT classes. Probably.
So you teach for a test master?
Yeah, that's not
Really?
Mm-hmm.
I was looking at the classes yesterday. There's someone told me that they could give me for the master. My RC team.
Really?
Michael, you know Michael Heath?
I do know Michael Heath.
Yeah, the Asian guy?
Mm-hmm.
Yeah, he's my friend.
Really?
Yeah.
Cool. Yeah,
He's really cool, huh?
yeah, Yeah, talk to him, see if he could.
Well, he did, but it's all for June, like June through June 29th.
You can't do it?
Yeah, that's like I'm on Zoom for everybody.
Okay. Yeah.
Yeah, you just tell him. But I feel like tell him good stuff about me.
Alright.
No, we've been friends for a really long time.
Really? How do you know him? Oh, through Tip? Yeah, he's a really cool guy.
Did you meet him at Rice?
No, I met him at Testmasters. I actually trained him because he came on after I did.
He went to, oh yeah, he went to Rice.
Yeah,
He went to Rice though.
He graduated.
Um,
I'm gonna tell him. I DM'd him on Twitter yesterday.
no, it's funny. I had a moment yesterday because I was talking to someone yesterday and I was like, "What are you doing this summer?" And they were like, "Yeah, I'm thinking of traveling or whatever." And I was thinking in my head like, "Oh yeah," because I this summer I've never been to the north. I've been pretty much everywhere around the United States. I've never been to the Pacific Northwest. You know, like Seattle or Portland. I've never been up there, and I would like to visit. So I wanted to go there, and I was thinking in my head, oh cool, they want to travel too. But then they bust out, yeah, you know, I've been to Asia like 3 or 4 times. I'd really like to go to Asia though, like this summer, you know, go to a different thing. And I just like looked at them like, man, like, it's going to Asia, and I'm sitting here like, yeah, I want to go to Seattle.
I went to Italy.
We went on a cruise. I want to go on a cruise.
They're fun. But my dad didn't like it because it's so cruise.
Did you meet any boys there?
How small were they? How small were they?
They're pretty small.
Did you text anybody when you were there?
Huh?
Did you text anybody when you were there?
How small were they though?
Wow.
I didn't have internet at my service.
Wow.
They were the beaches in Mexico.
You should be able to take pictures.
Were you like in the middle of the ocean or were you just like around?
You spend like a day at the ocean, a day at Mexico.
Yeah.
A day at the ocean, and then a day at
We go to several beaches.
So once you get back on the board, like a certain time?
Like you can get seasick because you don't even feel it when it's like moving, but you can still get seasick.
Yeah, because you don't like sense it.
My dad was like dying.
Yeah, I want to be able to do that. I'd be able to do that. I get car sick. Like if I like on my phone on the way to school, I'm just
All right, let's look at these.
Yeah, but like if I'm reading, you're really not.
All right, we're so close to the finish line, guys. We're almost there. All right, so first one's pretty simple. Just take the 4 in the front. Take 1 from the 4 in the exponent, you get 3. Second one, so the challenge there, although the challenge was, remember that when there's nothing written on a square, on a root, you just assume that it's a what? 2. You just assume that it's a square root. So here, it's x to the third 2, so you put 3 over 2 as the original function. You rewrite it as the fractional exponent. Then you do the derivative on that, pull the 3 over 2 to the front, and then you say x to the 1/2 because you say 3, 2, minus 1. And that's also, I've written it in the radical form in case you can always switch back and forth. Sometimes some people will want you to rewrite it as it was originally, but to me it really doesn't matter as long as you just have one of these two, it's fine. And then for C, again you have that negative exponent, so you want to make this 1 over x to the 5th a negative x to the 5th, negative 5th. Pull that negative 5 on the front, you get x to the negative 6. You can always put the x in the denominator too, like that.
What was your job before you started teaching?
Before I started teaching, I was I did the SAT classes for a while. And then I was, yeah. And then what else did I do?
Not doing it.
And then I was a PhD student before that, but then I quit.
Why?
Because it was like,
Mr. Logwinter.
no, it was more of well, one, I failed this test I was supposed to pass, and I couldn't continue in the program, to be honest with you. But I really didn't like, what's that? Yeah, well, it's kind of both. When you're in basically when you go to grad school after college, you take 2 years of classes, and really you're supposed to just be focused on your classes, getting up to speed as to where you were, and then you get your master's, and then after that what you do is you do 2 things. You actually teach classes at the college level. So typically, depending on the college you go to, you're probably going to get a graduate student to teach some of your introductory courses. So like probably Calculus 1 and 2, if you choose to take those, will most likely be taught by a grad student. And then in addition to that, you also start working on your dissertation. Do y'all know what that is? It's basically like you have to write a book on a topic of your choosing. So yeah. So for instance, I was in economics, and what I probably was going to have my dissertation on, it was either going to be on like probably having to do with gender economics, like seeing like economic models apply to like gaps in gender pay or stuff on SAT scores. I was also kind of interested in behavioral economics. Do you know what that is? Kind of just running experiments and seeing if people react to how the models say that they do in the theory. And sometimes they do, sometimes they don't. They do surprisingly amount of times. But anyway, I can go on and on about that.
You didn't finish the story, and then what?
About what?
About the whole thing.
Oh, so I didn't really like my program because it felt like I actually went to George Mason. Do y'all know about George Mason? It's kind of sleazy because it's kind of funded by the Koch brothers. And like I am libertarian, but even there it felt a little too like cultish, to where like if you didn't, because there were times when I was like, well, maybe this might be a reason for government to spend money on this, and people would just be like, oh my god, and I was like, we can't even have this discussion, come on, And so there was that, and also there was just kind of some sketchy things going on, like certain grad students would like get extra help, or would get help writing a research paper, or would like I would see them in the professor's office, or they'd get invited to like a New Year's Eve party from the one professor, and not everyone did, and it was just kind of like sketchy, like it felt kind of like a old boys sort of bureaucratic system, rather as opposed to like who's doing the best research or who's most interested in economics. So that's why I left. Yeah. What?
So don't go to college.
Huh?
Sounds like a bad.
I mean, this was grad school. Don't go to grad school unless you really, really like the program. Anyway, okay, so.
Is this your first job out of college then?
Kind of, like my first full-time professional job, yeah. This is my first one out of college, so first foray out into the real world, if you should say. Learned a lot this year. Right? Oh, I have,
like
yeah.
5 years from now, if you're still teaching, are you going to be like, yeah, my first year was horrible?
Yes and no. I think for me, yes, y'all got me off track, but I want to talk about this. I mean, it's the end of the year, so.
Come on.
So then we got to continue with the lesson. I don't think this year was a complete disaster, because I've seen a lot of other. Yeah. It was funny because there were some times when like I would teach in the first 2 months, and then like there'd be an observer, and I'd be like, oh god, that was a terribly taught class, right? And then they would come afterwards and be like, yeah, that was a great lesson, Michael. And I was like, really? But then one day I like started kind of going into other teachers' classes, especially middle school teachers' classes, and I was like, man, like, you know what I'm talking about? Yeah, it can get pretty bad at times. Especially, I'm sure y'all have gone through the experience where the teacher didn't know the material, right? Have you ever kind of gone through that? Yeah, that's.
No, I didn't know the material. They were trying to teach it to me, and I didn't know it.
Yeah, but once you're in that situation, like you're done. Like your management's gone, your credibility's gone. You know what I mean? And it's just like at that point. So, if I could say the one thing I would change about YES that was kind of bothersome that I didn't get at the teacher training is that I would really tell people know your content. Because if you don't know your content, you lose the confidence of all the students, and you're just done. Like, there's no way you can get it. There's no management techniques, there's no demerits you can give. If you don't know the subject, they're just not going to listen to you, so.
What teachers don't know the subject?
Alright, so moving on.
I have my daily meeting with,
Oh, really? I do too. So, now we're going to do this. So, again, trust me, this isn't going to take that long. So, that was all recorded. So, how is this different from the ones we just did? There's numbers, right? There's numbers. There's more than one term, right? Before it was already, yeah, there's coefficients here. And there's also more than one term, right? So let's see how we would deal with this situation. Yeah, so, yeah, pretty much. So what you're going to do here, is you're just going to treat everyone separately. And that's kind of the nice thing about differentiation, is that there's no special rule if you're adding terms together. It's just you can do differentiation on each term separately. So for instance, this one, you just do the derivative, right? So you're going to put the 3 in the front. Now, when you put the 3 in the front, you're actually going to multiply it by that 5 that's already there. So it's going to be 5 times 3, x. Still take the 1 away from the 3, so what's that going to be? 2. Okay? So that will give you 15x squared, right? Now, let's talk about this 4. So this 4, there's a few ways to think about what the derivative of this would be. Cassie in my 4th period suggested that maybe you could think of this as 4x to the 0 power, because what is anything to the 0 power? 1. So if you do the derivative on this, you get 4 times 0, x to the negative 1, but that doesn't matter because this is just 0, right? So that's cool mathematical algebraic way. But let's think about it a little more intuitively. Okay. So remember that the derivative tells you the slope of the tangent line, or the slope at that point on the curve, right? If we think about 4, think about 4 when you enter it into a calculator. What does that look like? If you just enter any number without any variables, what does the picture look like?
Oh, the line.
It's just like a straight line, right? You just see this straight line, right? Does that have any change? Does it ever change? No, it's just constantly 4, right? And remember, derivative is describing the change of the graph. So, if 4 has no change, what would the change of the derivative be? 0, exactly. So, with any constant, actually, the derivative of constants is 0. Because again, constants don't change. They're just constant, right? They just stay the same for the entirety of their function. So because of that, because they have no change, their derivative is thus 0. Let me ask you something else. If this was 5x cubed plus 1 million, would it matter? Would we still get this answer? Yes, because that constant would go away. And if you think about it, you're not really changing the shape when you're adding that. You're just moving it up, right? It's just a vertical translation. So it's still the same shape, but in a different place in the xy plane. Let's talk about b. So for b, what are we going to do with that x to the 5th? Yeah, let's distribute it. Only exponents. So here, when we're distributing, we're going to multiply x to the 5th times 2x to the 3rd. Now remember, when you're multiplying exponents, you're actually going to do what to them? You're actually going to add them. So here we're going to put that 2 in the front, the coefficient, so write that 2 in the front. But it's going to be x to the 3rd plus x, or times x to the 5th, so this is going to be x to the 8th, because you add 5 plus 3. And then, obviously, if you multiply 4 times x to the 4th, you just get x to the 5th. And now we can do the derivative. So at that point, it's simple. You just say 8 times 2, which is 16, x to the what? 7th. Plus, what is this one going to be? 20x to the 4th. Good. Exactly. Sure. All right, let's talk about C, and then we are done learning new stuff for pre-calculus. Yay. Okay, I'm kind of sad, but not really. Okay, let's go ahead and look at this one. I'm going to rewrite it because it came out a little small in the printing. So 12x plus 6. And also, I just like rewriting problems because it kind of helps me internalize it a little more. There's been times when I couldn't really understand a problem, and then once I kind of rewrote it, I was like, oh, I know what it's talking about now. So, this looks very complicated and very, like, it might take a while, but it actually really doesn't. So, the first thing we got to remember is that when we see this long bar of x underneath a lot of terms, we remember that this denominator applies to every single one of these terms. So what can we do because of that? Well, let's just separate and write the denominator under each of them. So, we're going to say 5x to the third divided by x minus 12x over x plus 6 square root of x to the fifth over x. Okay. And so one nice thing is that allows us to see that we can cancel stuff or kind of combine some x's, right? So for instance, in this first term right here, what happens when you divide exponents with the same base? You subtract their exponents, right? So this is going to be 3 minus 1, so this would be 5 times what? X squared. Good. So again, we're just still writing the function. We haven't done the derivative yet. Minus 12. Why is it minus 12? Yeah, the x's cancel here, right? You got an x on the top, x on the bottom. In the top, we're going to have to be a little more clever. We're going to have to remember again that when I have a radical here, what is this? What can I change this to? X to the what power? Not negative. 5 over 2. Right? 5 over 2. You want to do it. The number that is getting exponented is and then the number that is the root. And remember, if there's nothing written there, you assume that it's what? 2. It's a square. All right, so x to the 5 over 2 divided by x. Remember, you subtract exponents. So 5 over 2 minus 1. X to the 3 over 2. Remember, 5 over 2 minus 3 over 2. Or sorry, 2 over 2, which is the same thing as subtracting 1. And then, yes, the 6 goes in the front. Thank you, Josh. Go. And what's our last step? The derivative. We got to find the derivative. Yes. And notice the derivative actually probably is the easiest part of this, right? You just put the 10x. What happens to the negative 12? Subtract. Nothing? Wait, what? Subtract. Yeah, it's a constant, right? Negative 12. So it just goes away. Oh, sorry. And then you take the derivative here, plus 6. What am I going to multiply that 6 by? Three over 2, right? I bring that exponent down to the front. And then x to the what power would I do with this? Subtract what? 1. So it's going to be 1/2. Yes, good. And so then, simplify that. You can either say 6 times 3 over 2, or 6 divided by 2, which is 3 times 3. Either way, you'll get 9x. And that is our answer right there.
Wait, what did you say happened to the 12? What did you say happened to the 12?
The 12, remember the 12 is a constant. And whenever you find whenever you're taking the derivative of a constant, it's just 0.
Oh, yeah.
Okay, so I'll take this opportunity really quick to kind of say that, so somebody asked me earlier, so if you'll notice, this was the only calculus we did, was right here. All of this was what? All of this was algebra, early pre-cal, right? So somebody asked me, hey, if calculus, as you've said, is easier than pre-cal, should I still try AB? And my recommendation to you is this. Look, calculus, to me, the concepts and the ideas are fairly easy to wrap your head around. Pre-cal and algebra is where things get kind of confusing. So if you choose to take a calculus course, whether in college or next year, here, most of the problems you're going to run into are not going to be understanding the calculus. They're going to be what? In the algebra part. So just know that if you're taking calculus, your algebra skills are going to improve, but if you struggle this is where you're going to struggle. So just know that going in, when you make that decision, that is where the challenging part is. Okay? So,